Okay, students, today we're going through the topic financial mathematics. Okay, this chapter, I think most of you should know by now that it's from your paper one, and it counts like plus or minus 15 marks on your final exam. So that's not a lot, but it could help you out to get a distinction for your math. Okay, the first thing that you should remember in this chapter, I'll just go through the stuff that you did in your grade 10, which is your simple interest and your compound interest. Okay, with your simple interest, remember that you were introduced to the formula A equals to P into 1 plus IN, and then for your compound interest, it was A equals P into 1 plus I to the power N. Okay, the only difference between the simple and the compound interest is that for your simple interest, you just calculate interest on the initial amount of money that you invested, but on your compound interest, you calculate interest on the accumulated amount. Okay, and also another important thing is for you to know your variables, where your A is your accumulated amount, your P is your initial amount or your initial investment, your I is your interest rate, and then your N it's your period of investment. So they wouldn't ask you anything on the exam based on simple and compound interest. So I'll just move to another concept that you did in your grade 11, which is depreciation. Okay, for depreciation, remember the definition for depreciation, it's whereby your fixed asset, you lose their value as you use them, which means that suppose that you buy a car. Remember, it's an asset to you because you bought it and you bought it for your usage. So if you buy a car and then you use it, when you sell that car after using it, you won't sell it at the initial price that you bought it. Okay, let me show you this in a formula. Let's take the simple, the straight line method for your depreciation, which is A equals P into 1 minus IN. Okay, the variables, they might look the same here on depreciation. You could see between depreciation and your simple interest, the variables are the same, but the definitions of your variables are not going to be the same because your A is not going to be your accumulated amount of depreciation. It's going to be your book value, or you could call it your scrap value. And then your P is going to be the price of an asset, or you could say the value of the fixed asset. And then your I, it's your depreciation rate. And then your N, it's the period of depreciation. Okay, like I said, that here, the value or the initial price of your fixed asset is not going to be the same as the book value of your asset or the value of which your asset has depreciated with, which means that your A will always be less than your P. Why am I saying your A is going to be less than your P? Remember that the initial price of which you bought your asset with, suppose you bought the asset for 500,000 rand. Okay, after buying an asset for 500,000 rand, when you sell that asset, you're not going to sell it with for a price that is greater than 500,000 rands because it has been already used, which means you have to sell the asset at a price that is less than 500,000 rands. That's why your book value is always going to be less than your initial price because the value of your asset is decreasing. So that's the concept of depreciation. And some other stuff, or the question that they might ask you based on the simple interest, compound interest, and your depreciation could be questions of inflation. You know that inflation, it's the rise of prices. So if the prices rise, you know that you have to use your compound interest formula because it shows that the prices are increasing, and then for deflation it's going to be the opposite of inflation, which is going to be your depreciation formula. And then for population growth, if your population is growing, you use your compound interest formula, and then if the population is decreasing, you use your reducing balance formula of depreciation. And I'll just quickly go through this graph that's going to explain every concept. Let's say on your x-axis you've got your time in years, and then in your y-axis you've got your amount in rands. Okay, and then I insert 450,000 here, and I do something like this. I give you 4 to 120,000, and then here I give you 4 to 620,000. Okay, this simply means, this simply shows that this is the initial price of which you bought your asset with, or this is the initial price of the asset, and then after 4 years, what happens to the asset? It depreciates to a price of 120,000, and then from here, if you go up or use this other lane of your graph, you'd see that this was the initial price of your asset or of whatever thing that you bought, and then after 4 years, this is going to be 620, which shows inflation. So this is how inflation and depreciation differ, or deflation and inflation differ. The other one increases and then the other one decreases. If you want more of financial math, please check out the next video whereby we'll discuss annuities and more of the other concepts of financial math. And if you like my videos, just subscribe to my channel. I'll try by all means to upload more videos of other concepts on your mathematics. Thank you very much.